Welcome to VST. This is part 2 of clean architecture with dynamic role-based permissions in C#. In this video, we'll focus on some core building blocks of our architecture: solid principles, extension methods, identity user application, building custom user management, and configuring entity framework properly. I highly recommend to watch part 1 before proceeding. This is the same project that we have been working with so far in this video series. Create a new base entity class and common folder under domain layer. This is the base entity class, and it's the foundation for all our database entities. Here we have ID property. This is the primary key for every entity in our database. Using an integer, ID is efficient and works well with SQL Server's identity columns. Next, we have the audit properties like created by, created at, updated at, and updated by. So what is this class doing? It's an abstract base class that provides common properties and behaviors for all our domain entities. This means every entity in our system, like students, teachers, courses, will inherit from this class and automatically get these properties. Now let's look at the constructor. Two important things here. First, it's protected. Only derived classes can call it. You can't create a base entity directly. Second, it automatically sets created at to the current UTC time. This is a huge time saver and ensures every entity gets a creation timestamp automatically. Now we will create enumerations like user type. First we have superadmin. Next is academic, principal, teacher, and student. Same as we have user status active, inactive, suspended, and locked. Enum makes your code cleaner, safer, and more meaningful compared to using raw numbers or strings. Now we will create application user class, which is a rich domain entity that encapsulates both data and business logic. It follows principles like encapsulation, single responsibility, and domain-driven design by controlling its own state and behavior. Instead of handling logic and services, we keep everything inside the entity to make the system clean and maintainable. This is the heart of our authentication and user management system. Application User is my custom user class that inherits from Microsoft Identity User. Create some property like first name, last name, user type, and so on. The user personal information. I made the parameter lessConstructor private. Why? Because I want to enforce that users are created through my parameterized constructor, which includes validation. This prevents someone from accidentally creating an invalid user object. But Entity Framework needs a parameter lessConstructor for materialization from the database. By making it private, I satisfy EF's requirement while maintaining encapsulation. Initialized all property with constructor parameter, like first name, last name, and so on. Here, immediately validate the names. This is called fail-fast principle. Validation happens immediately. When creating or updating, I throw exceptions early, rather than letting the object enter an invalid state. I extracted this validation into a separate method for 3 reasons. 1. Reusability. It's used in both the constructor and the update profile method. 2. Readability. The constructor and update method stay clean. 3. Domain validation. These are business rules. First and last names are required and have length limits. I'm using my custom domain exception class here to represent domain-level validation failures. This is a custom exception class, domain exception, that extends the base exception class, allowing you to throw domain-specific errors with optional messages and inner exception details. Here's my method for updating user profiles. This method encapsulates the behavior of updating a user's profile. The profile picture is optional with a default of null. Notice, I reuse the name validation logic. I update the updated at timestamp automatically. Update user type method updates the user's type and records the current UTC time as the last updated timestamp. Next, update status. This method updates the user's status and sets the current UTC time as the last updated timestamp. Record login method records the user's login time and resets any failed login attempt count. Reset failed login. Attempts method resets failed login attempts, unlocks the user if locked, and updates the last modified timestamp. Record. Password change method records the password change time and updates the last modified timestamp. Confirm email method marks the user's email as confirmed and updates the last modified timestamp. Get full name method returns the user's full name by combining first and last name, removing extra spaces. Is locked out method checks if the user is currently locked out based on lockout settings and expiry time. Can login method checks if the user can log in by validating email confirmation, lockout status, and overall user status. Now, here can login method does not exist in user status enum. We create an extension method by defining a static class and a static canLogin method, where the first parameter uses the this keyword to extend the user status enum, allowing us to add custom logic. Get remaining attempts method calculates how many login attempts are left, returning unlimited attempts if lockout is disabled. Get lockout minutes. Remaining method calculates the remaining lockout time in minutes, returning 0 if lockout is disabled or expired. Should apply lockout method checks, whether lockout should be applied based on global settings and user lockout configuration. I applied here, single responsibility principle. This class only manages user-related behavior. It doesn't handle database access or UI concerns. Domain-driven design. This is a domain entity that encapsulates business logic. I put behavior where it belongs with the data factory pattern. I use constructors as factories to create valid instances. This interface defines a contract for saving changes to the database asynchronously. It abstracts the database operation, so different implementations can use it without depending on a specific data access technology. Now, we create application DB context. By inheriting from identity DB context with custom types, like application user and guide, which sets up all ASP.NET identity tables with our own configurations. We also implement application DB context for abstraction and use the constructor to pass database options to the base DB context. This method overrides save changes async to handle saving data asynchronously, and simply calls the base DB context implementation. Now, create update audit able entities method. This method tracks all entities that inherit from base entity class and are either added or modified. It automatically sets created at when a record is new and updates updated at every time the entity is changed. In on-model creating, we customize how identity tables are mapped in the database. We rename default ASP.NET identity tables, like ASP.NET users, to cleaner names such as users, roles, and user roles. We also set schema U and adjust column names like ID to user ID for better structure and readability. Now, identity table has been configured. Now we will move this code into identity table method. Here we configure the application user entity by setting rules for its properties. Like required fields and max lengths for first name, last name, and status. We also store status as a string and ensure created at is required. Additionally, we map isEmail confirmed to the existing email confirmed column and ignore the default property to avoid duplication. This is code that we developed so far. This application DB context manages database operations by integrating ASP.NET Identity with custom entities and configurations. AppSettings.json file helps us manage database connections, identity settings, JWT authentication, and other application-level configurations. First, we have the SQL connection section, which contains our database connection strings. Inside this, we define multiple environments like local and production. In the local environment, we have a connection string for our database named LMSDB. This includes the server name, database name. The production connection string is currently empty, but in a real-world application, this will contain the live database configuration. Next, we have the app settings section, which contains all custom configurations of our application. This includes identity settings, JWT authentication, and email configuration. Now let's move to identity settings, which control user authentication and security. In the password section, we define password rules. For example, the minimum password length is set to 8 characters. In sign-in settings, we require users to confirm their email before logging in. In the lockout settings, if a user enters the wrong password multiple times, their account will be locked. After 5 failed attempts, the account will be locked for 5 minutes. This helps protect against brute force attacks. Now create app setting class that help us map the app settings.json configuration into C# objects using the options pattern. First, we have the main class called appSetting. This acts as the root configuration class. It contains identity settings, which holds all authentication-related configurations, and a Boolean flag is sendEmail to enable or disable email functionality. Next, we have identity settings. This class acts as a container for all identity-related configurations. It includes password settings, sign-in settings, user settings, and lockout settings. In lockout settings, we will map lockout appSettings.json configuration with C# objects. In lockout settings, we define account security rules. If a user fails to log in multiple times, their account will be locked. Here, after 5 failed attempts, the account is locked for 5 minutes. In user settings, we define rules related to users. Each user must have a unique email address. We also specify allowed characters for usernames. In sign-in settings, we control login behavior. Currently, email confirmation, phone confirmation, and account confirmation are all disabled. This means users can log in without verification. Inside password settings, we define password rules. For example, the minimum password length is set to 6 characters. We are not enforcing uppercase letters, digits, or special characters, which makes this a relaxed policy. Now, we will check mapping of identity settings, password, lockout, sign in, and user with app setting. So overall, these classes help us keep our configuration clean, structured, and strongly typed. This approach improves maintainability and follows clean architecture principles. Now, we will create a static class to register services. This is a standard clean architecture pattern. Add infrastructure is an extension method that extends iService collection interface. Reads app setting from appsettings.json, converts it into strongly typed object, registers it as singleton, meaning one instance for the whole application accessible anywhere via DI. Next, registering entity framework. DB context. First try to get connection from default. If not found, then get from SQL connection : connection strings. :local : LMSDB. Ensures migrations are created in the same project as DB context. The main benefit of this implementation is that it centralizes all infrastructure-related configurations in one place. We are following clean architecture, so database and identity configurations are handled inside the infrastructure layer. Next, we configure ASP.NET Identity using our custom application user and identity role. Instead of hard-coding values, we will read all identity settings from app settings. We dynamically apply password rules such as required length and character requirements. Then apply user setting and then account lockout rules, such as maximum failed attempts and lockout duration. Then apply sign-in setting. Finally, we connect identity with entity framework and enable default token providers for features like password reset and email confirmation. Now, register the application DB context with an interface using dependency injection. So whenever the application requests iApplication DB context, the DI container provides an instance of application DB context. Now we can call extension method like as builder.services.addInfrastructure. Identity Service Interface is an abstraction layer that sits between our application logic and the identity framework. It follows the Interface Segregation Principle, ISP, from Solid. It decouples business logic from the underlying authentication implementation, making our code testable and maintainable. We have methods to retrieve users by ID, email, or username. We also have create, update, and delete operations. Notice the tuple return type. This gives us a clean pattern for handling success and error states without throwing exceptions. Role management allows us to assign and remove roles from users. We have check password async for login validation. For email verification, we generate tokens during registration and confirm them when users click the verification link in their email. Password management includes two distinct flows: generate password, reset token async, and reset password async handle the forgot password scenario. Change password async handles the change password scenario where users provide their current password for verification. For security, we have lockout functionality. This is used after multiple failed login attempts to prevent brute force attacks. Now let's dive into the implementation of the identity service. Inherit the interface identity service with this class. Press Ctrl+Dot to implement all interface. User Manager is the core identity operations, like CRUD, passwords, roles, and lockout. Role Manager is for manage roles. Application DB Context for direct database access for complex queries. iLogger for structured logging for auditing and debugging. One of the most interesting features is Add to Role Async. It automatically creates roles if they don't exist, making our system flexible and self-configuring. It also logs every role assignment for auditing purposes. For password changes, we implement a password history system. When users change their password, we call record password change method on the domain entity to track when passwords were last updated, enabling us to enforce password rotation policies. Email confirmation is a two-step process. First, we generate a token with generate email confirmation, token async method. Then, when the user clicks the verification link, confirm email async method validates the token and updates the domain entity with confirm email method. Next, we will implement create user async method for creating user. Then, by implement delete user async method for deleting the user. We generate a token with generate email confirmation, token async method. Next, we will implement generate password reset token async method to generate new password. Then, by get user by email, async method to get user by email. Same as for get user by ID async and get user by username async methods. Add implementation for the rest of methods like get user roles. Async is in role async to check user has role or not. The lockout system is implemented with configurable duration. When a user is locked, we update their status to locked in the domain, and identity sets a lockout end date. Administrators can manually unlock accounts using unlock user async method. Every method returns a tuple containing a success flag and any error messages. This follows the result pattern, allowing our application layer to handle errors gracefully without relying on exceptions for control flow. This implementation uses several patterns. Repository pattern through the user manager abstraction. Result pattern for error handling. Dependency injection for loose coupling, and domain-driven design with rich domain entities containing business logic. This is code that we developed so far. Registers Identity Service interface with its implementation Identity Service class in the DI container using a scoped lifetime, 1 instance per request. The Identity Service class depends on 4 key components: User Manager for core identity operations, Role Manager for role management, Application DB Context class for custom queries, and iLogger for structured logging. It also interacts with our application user domain entity, which contains rich business logic. If you found this video helpful, please hit that like button and subscribe the channel. It's really motivate me.